Hi Lee Yang. You have asked about theorem 4.2.5 and theorem 4.2.6, as well as exercise 22 in exercises 4.2. There's quite a lot of content covered in that. So the first thing I'm going to do is I'm going to explain theorem 4.2.5. But before doing that, just covering off on theorem 4.2.4, and I'll leave this video just at that, and then I'll attack theorem 4.2.6 in another video. So by the sounds of it, you understand what's going on in theorem 4.2.4. So the theorem states that the solution space of AX equals the zero vector is a subspace of Rn. So just to recap, we have a M by N matrix A, and X is in Rn, so it's N times 1, and therefore our zero vector has to be M times 1 to be consistent. So they give a few examples in the textbook of what the solution space is, and essentially they're saying these solutions are their own subspaces. So in R3, say 3 dimensions, the solution space might be a plane or a line or the zero vector itself. So by the sounds of it, all of that's okay. And as they say in the textbook, theorem 4.2.5 is just a restatement of this. So the way I would think about theorem 4.2.5 is if we have X part of n-dimensional Euclidean space, we can define a transformation using the matrix A, transforming any vector X in Rn by way of the matrix A into a vector in m-dimensional space, and this itself is a subspace. So just to write it out, as we had before, if we have AX, we've essentially got A, which is an M times N matrix, and we've got X, which is an element of Rn. We end up getting a M times 1 matrix, which is an element of Rm, which is equal to M times 1, the zero vector, M times 1, that will do. So it is simply a restatement of the previous theorem, and it may not potentially be that helpful for this course, but essentially it's just pointing out when you apply the matrix A to a vector in n-dimensional space, you actually get an m-dimensional vector in the end. I don't think there's anything deeper that you need to glean from this theorem, so I'm going to leave this video here, and then I'm going to have a go at the next theorem and the question, exercise 22 that you asked about. Okay, thanks.